All right, so this is where we left off. We were talking about how the spinning drum can create a feeling of gravity. It's not real gravity, because real gravity is created by mass, okay? But artificial gravity is created by using your inertia and having something block it, the floor, okay? In this case, the floor of the spinning drum. So even though I want to go this way, if I'm standing here where this person is, my inertia wants me to leave the circle perpendicular to the center. Okay. However, I'm prevented from doing that by the rounded nature of the drum, which pushes me directly back towards the center and feels like gravity. Okay. No matter where I am in that drum, as long as I'm not in the middle of it, okay, I'm going to feel some gravity. Now, that's going to depend on how close to the center of the drum I am, how big the drum is, how fast the drum is spinning, okay, all of that kind of stuff. And that would be something that on a long space voyage, they would take into account. Okay, if you were headed to Mars, you'd probably go under normal Earth gravity for part of the trip, and then they would probably back it off to something more like Mars normal gravity so that you would get used to what it feels like to be in Mars gravity. You don't want to get down on the surface and be, falling all over the place because the gravity is so much different than what you're used to. Okay, so they would probably do something like that just to get them back to normal. Then on the way back from Mars, they'd probably crank it up, because they want to get nice and buff for all the photographers when they get home. Crank it up to like 1.5 Gs or 2, right? So that you get like hugely ripped on the way home, okay? So that you look good on the beach. But yeah, these are all things that they could adjust, okay, while they were moving, because it's all related to how fast the drum spins. So this idea has been around for a very long time. It's not something new. We see it in science fiction movies now, but it was actually put into one of the original great science fiction movies, and that is 2001: A Space Odyssey. Okay? In 2001: A Space Odyssey, which is a movie that's older than me, okay, so it's really old, right? They had built a set that spun, that was like the spinning drum of the ship that was creating the artificial gravity, because they knew this was how they would likely do it whenever they got the chance. Now, this movie was made, I want to say like late 60s, early 70s, pre-Star Wars, that kind of thing. Okay, so they have this part of the set that spins, and what they do is the people are always on the bottom of the drum. So they film it from cameras that are stationed on different parts of the drum to make it look like they're moving, okay? Except they're actually not moving. It's the drum that's moving. They just stand at the bottom of the drum and walk, okay? And so the drum is always spinning, but it makes it look realistic. The only issue is if you have one of them on this part of the drum and one of them's supposed to be somewhere else. It's a spinning drum and it's filmed on Earth. It isn't a real like artificial gravity thing. So the other person would have to be sitting and strapped in. So they would have a seatbelt here at this table thing, okay? And the guy would actually go upside down while the other person's on the bottom, making it look like the whole thing is going on for real. Okay? They won like basically every Academy Award for set design and special effects that there was to win back then, okay? For all the stuff that they did here to make this look realistic and such. Okay. In fact, some of the scenes, because this is pre-CG, okay, right? This is way before computer graphics and animation, stuff like that. Okay, some of the stuff was actually filmed on NASA's zero gravity trainer, okay, called the Vomit Comet. Okay, that's what the astronauts call it, because it goes up and down in the air to simulate gravity and zero gravity. So they filmed scenes in short bursts, just like they did with Apollo 13. Okay, about 30 seconds at a time, they would shoot these scenes in order to make the zero gravity scenes look realistic. All right, so I'll show you a couple of the clips from that movie, and you can see just what they thought things were going to look like in 2001, which oddly enough now is in the past, but okay, for them it was 30 some years into the future. They had some strange ideas about what things would look like and stuff. Okay. All right, so that's how we would make that work. Okay, so here's the type of question you would get or problem you would get to do with artificial gravity. Okay, we're looking for what speed the surface of a station that has a radius of 1,700 meters, so like the big wheel we saw at the beginning of that video. Okay, how fast does it have to move so an astronaut standing right here feels a push on their feet equal to what they would feel in Earth gravity? All right, so we're using centripetal force to feel like what force? Like the force of gravity. It's not really the force of gravity. It's the normal force of the station pushing it back against us with a force equal to the force of gravity. So what we really end up with is this. mv squared over r equals, right? If we want it to feel like gravity, we make it equal to gravity, right? We know the radius. They told us it's 1,700 meters. We know we want to feel like we're at home. What don't we have? Do we need the mass? No, everyone would feel like they're at home, regardless of their mass. Mass is going to cancel as soon as we start manipulating anything here. So we're looking for V, so I'd multiply both sides by R, M would cancel, and I would take the square root of that, so I'd have V as the square root of GER, not mu-GER, just GER. Okay, G times R, okay, and that'll be 9.81 times 1,700. All right, so about 130 meters per second is how fast it would have to spin. Okay, that's pretty fast. But the bigger the radius, the faster it's going to have to spin. Okay. All right, everybody okay with how that one works? Okay, that's really all there is to artificial gravity. Centripetal force equals the force of gravity if we want it to feel like gravity at home. All right. Okay, so like we said, it's not really a new idea. Arthur C. Clarke wrote a lot of books where there would be this spinning tube idea. In fact, one of the big ideas for a spacecraft that would take people from Earth to another solar system is a giant cylinder. Okay, make the ship a big giant cylinder so the entire interior surface of the cylinder can be used as a living area. Okay, they do this in Interstellar. If you've seen the movie Interstellar, at the end they're in a big cylindrical spacecraft, and when they look up, they can see on the horizon like the other houses are upside down, looking down at them. Okay, but it wouldn't seem like they were upside down, right? The problem would be if you hit that baseball. Okay, just like what happens in that shot in Interstellar, the kid hits the baseball and he breaks a window of a house that's like upside down on the other side, right? Again, if you get that baseball moving up and away, the gravity pulling on it significantly decreases, and so it wouldn't fall in the true arc. It would do something weird, okay, as it would go along. One of the things that Arthur C. Clarke pointed out would happen, okay, or at least theorized would happen with this, would be how the water cycle would work inside. Right? You've got to have, a source of light, so you'd have artificial lights in there of some kind. Okay, but the water cycle would have to work. So you'd have water that would evaporate and it would rise, but it can't go all the way to the other side. It would go to the middle. So you'd get tubular clouds forming in the middle. Okay. Now, the other part of it would be that it would be hard for rain to fall out of that cloud because where the tubular cloud forms, there's no gravity. Okay, so what would happen is you would have to periodically accelerate and decelerate the ship in order to force the water to one end or the other, where it would hit the end of the ship and then fall down. Except, how would it fall? Would it fall straight? No, you'd get a curved waterfall at the end of so you'd have this circle and the water would fall like this. So you'd be looking at the end of the ship and see this waterfall that goes like this. You learned about why that would happen in Science 10. It's called starts with C. It has to do with winds being deflected on Earth. Coriolis Effect. Okay, the Coriolis Effect. You should have learned that in Science 10. Anyway, okay, if you're on a spinning object and you try to walk straight, you can't. You curve automatically, okay, and that's what would happen there as well. So just some weird things that would likely happen. Okay, so we'll call it there.